Alright, so let's look at question 12. A small positively charged particle P is balanced. So balance just means resultant force is 0. Halfway between two horizontal plates when a potential V is applied between the plates. When V is increased, P rises. So when you increase V, P move up towards the positive plate. Move to the upper plate. And when V is decreased, P falls towards the lower plate. Okay, so now, we have some statements right below, right? Which of the statements is correct? So the statements actually include the electric potential energy and the gravitational potential energy. So like we want to kind of see whether decreasing V will change the electric or potential energy, and how does it change, whether it increases or decreases them. Okay, so essentially, so let's take a closer look at the problem. Alright, so now we have the question gives us that P is positive. So let me just write this here. Okay, P is a positive charge. Okay, and as always, gravitational force always points downwards. So we have F1 equals to mg again. Right, that's quite similar to most of the questions. And then we have for it to have a resultant force 0, because the cell is balanced, they must have an upwards force of F2, let me call F2, which is the electric force, equals to EQ. Okay? Alright. So when the resultant force is 0, EQ is balanced by mg and it's stationary. But what happens? Okay, so how is V related to the electric field, right? The electric force. So F2 will be equals to EQ, and E, if you look up your equations table, you have V over D times Q, right? So E is actually just V over D. So what happens if you increase V, right? If you increase V, okay, now if this is positive, for it to have a upward force, this must be negative, right? Because opposite charges attract, right? And then so this must be positive, right? So that positive and positive repel, so it produces an upward force, and negative and positive attract, so you have a upward force. Okay, so this is how we guess that the upward force is negative, more negative than the lower force, than the bottom plate. Sorry. So when you increase V, P rises to the top, right? Rises to the upper plate. What happens when when P rises? This means your mgh increases, right? If P rises, right? mgh increases, and if P moves to the more negative plate, the E electric potential energy, right, must decrease. Why is that so? Because EPE, electric potential energy, is given by VQ, right? Since Q is positive and it moves towards a more negative plate, so V is becoming more negative, that means your electric potential energy is becoming more negative. It's something like, let's say here it was at 1, right? It's at 1 volt, right? And then it moves up, it becomes negative 3. So from 1 to negative 3, you notice there's a decrease in the electric potential energy. Okay, so that's just for example. So if P rises, mgh increase because it moves up, and then as it moves closer to the negative plate, electric potential energy decreases because V becomes more negative, right? Similarly, if P falls, what happens? Your mgh, which is your gravitational potential energy, decreases because now it's closer to the ground, right? So H has decreased, so mgh decreased. But what happens to your EPE, right? Your electric potential energy. Sorry, just let me shift this. Your EPE is, if your positive charge moves closer to the positive plate, your EPE will increase, right? Same thing, if this is 1, earlier is 1 volt, and then it moves lower to, let's say, 5, positive 5. From positive 1 joule to positive 5 joules, you notice there's an increase, right? From 1 to positive 1 to positive 5. Notice is an increase in EPE. So If V decreases, P falls towards the lower plate, MGH decreases, and EPE increases. So let's look at the statements, right? You don't need the diagram anymore. Okay, if you decrease V, both electric field, electric potential energy and gravitational potential energy decreases, right? But this is wrong, because if you decrease V, although MGH decrease, right, but electric potential energy increase, right? Electric potential increase, so A is wrong, because electric potential energy increases rather than decrease. Okay, notice the increase here. How about B? If you decrease V, you increase EPE and you decrease gravitational potential energy, which is correct, right? Decrease V, MGH decrease, EPE increase, so B is correct. How about C? If I increase V, both my electric potential energy and gravitational potential energy increases, but it's wrong, right? Even though MGH increase, EPE decrease, so C is wrong. Okay, now D is a bit tricky. Okay, the change of electric potential energy must equal to the gravitational potential energy. Well, this may, I think most students will pick this, but it's actually wrong. Why? Because now let's say this the resultant force is no longer zero. So, now let's say the resultant force is no longer zero, and this the charge starts to fall down, right? Why? Because your downward force is greater than your upward force, resultant force not zero, and it starts to fall down. What happens when it starts to fall down is your MGH will decrease, right? It will decrease. And then one of the laws of physics, which is the most holiest law, is that energy must be conserved. So if MGH decreases, where does it go? And you learn in your dynamics that, or kinematics, that actually your KE also, some of it will go to your KE and some of it will go to your EPE, as we have seen here, right? In this case, as it moves towards the more positive plate, your electric potential energy must have increased, right? So MGH decrease, some of it will go to your KE and some of it will go to your EPE. So it need not, A equals to B plus C need not mean that A equals to C, okay? Although I must say that as it goes down, even though it gains some kinetic energy, as it goes closer and closer to the plate, the repulsive force between the positive plate and the positive charge will become so great that KE will eventually be zero. But the point will still touch the plate.